Hello, everyone. My name is Natalie Parker. I am a 21-year-old chemistry student from the University of Northern Iowa. Over the fall of 2020, I participated in a course titled Instrumental Analysis under the instruction of Dr. Joshua Seabree. In this course, I conducted my own mini research project using the LEGO Mindstorms program. In this video, I will give you an overview of my project, the method, and the results that I found over the course of the last 3 months. So, I am very interested in the chemistry behind the cosmetics industry and how the products that we use impact us over a long period of time. My initial idea for this project was to test different makeup products to find if there was a direct correlation between the pH of makeup and the impacts that it would have on someone's face. I built a robot that dipped a calibrated pH probe into my sample and then cleansed itself in distilled water. So, a little bit of background for my non chemistry friends. pH is a logarithmic scale that examines the presence of hydrogen and hydroxide ions within a liquid. It ranges on a scale of 0 to 14, where 7 is a 1-to-1 ratio that is considered to be neutral. A lower number is the presence of more hydrogen ions and it appears more acidic, while the higher number is more alkaline because it has more hydroxide ions. To give a reference, the visual shows common household items and their pH scale. So for an example, the lemon has a pH of 2 because it's super acidic, while soap has a pH of around 12. To complete my research, I built a robot using the LEGO Mindstorms EV3 set. My robot, nicknamed Peter, holds a pH probe that can move in either the direction of my sample or it will stay in its main location. In this slide, I have a couple pictures of Peter. This is how his code works. It first wakes up and moves to a predetermined height and moves back and forth. Then it'll wait until I say which direction I want it to go in and confirm. It goes to the sample and slowly lowers into a 100 milliliter beaker, and the probe activates and reads for 60 seconds. Then it goes back to the distilled water and reads for another 60 seconds. It'll raise back to its ready state so I can change out the sample and restart. I have a video of Peter in action. This is after the sample has been read and it travels back to the distilled water. The pH increases gradually because, as I will discuss later, this was very acidic.
And then you want to get buffer again well as it goes out. As it's going back to its neutral, because that's just distilled water.
So the pH probe had to be calibrated manually. The LEGO Mindstorms brain reads the voltage while the pH can of course read pH. I found the pH of 17 samples including hydrochloric acid, sodium hydroxide, distilled water, and buffers. Using the Logger Pro and the trend line from voltage to pH, the LEGO Mindstorms brain could then be calibrated to read pH properly. Now for the fun part. Once Peter was fully functioning, I was able to test my makeup products in question. I tested each of them using Peter. Each sample was gotten from Target with prices ranging from $4.69 to $10.99. I chose them out of similarities in their marketing for daily usage and cleansing. First, we have the Dickinson's Witch Hazel Toner, the Cetaphil Makeup Remover, Neutrogena Makeup Remover, Thayer's Witch Hazel Toner, Burt's Bees Micellar Water, and finally Garnier Micellar Water. I tested each of these twice using Peter and compared my measurements, cleaning out the distilled water each time in case there was any leftover sample that contaminated my water. I used 100 milliliter beakers that contained about 80 milliliters of sample. For the results, the pH of each was the following. Dickinson's had a pH of 3.3218, Cetaphil had a pH of 6.4806, Neutrogena resulted in a pH of 6.0725, Thayer's had a pH of 5.3062, Burt's Bees had a pH of 4.9417, and Garnier had a pH of 6.9655. This wide range really made me think, and since they're all marketed the same, I was curious on why the range was so large. The standard pH of your face ranges from 5 to 6, so it's a little bit more acidic. This is because the skin oils on your face protect you from bacteria and moisture. When your pH is higher, you're lacking these important oils, so the symptoms you might see is dryness, skin irritation, and redness. On the other side, if it's too acidic, then you're going to be producing too much oil. This results in more acne, a burning sensation, and it'll be an increased amount of sensitivity. Each person's skin is different, so Some people will produce more oils or less oils. This means that if your face is more oily and greasy, you should use products that accommodate for such. You should use products that range from 5 to 7 in pH. You should avoid products that are more acidic because they're just going to make you more uncomfortable. On the opposite side of the spectrum, if you have an increased amount of dry and flaky skin, you could use those kind of products. So you want to use things that range from 5.5 to 6, or yeah, so 5.5 to 6. If there are more products that are outside of the range of 4.5 to 7, you really don't want to use those kind of products because you could be severely damaged by those kinds, and they might cause permanent damage. Here's a visual of all of my samples and how they fall onto the pH spectrum. The most alkaline is the Garnier micellar water, which is just pushing a pH of 7. On the opposite side, the Dickinson's had a crazy pH of 3.3. So what this means is it is the most surprising because even if you had the most dry skin, this might cause permanent damage to you, and it could cause you to have a more acidic face over time, especially if used daily as it's marketed. Now, pH isn't the only thing that you want to think about when figuring out what kind of products you want to use, but this is just my particular point of interest. If I was to look further into this research, I would go into more the specific acids and bases that were used for each sample. And with my alkaline samples, there was both an aqueous and organic layer, which I thought was very interesting. I want to thank the University of Northern Iowa for providing me with the LEGO Mindstorms set and funding my research, and I would also like to thank Dr. Seabury for helping me through this process. Thank you.